Okay, today we'll discuss about polymorphism. Polymorphism basically means having multiple forms. So the topics that we'll discuss is introduction, types of polymorphism, static, and then dynamic polymorphism, and how these are implemented. Am I clearly audible to all of you? Yes. Am I clearly audible?
सर आपकी आवाज़ कट कट के आ रही है।
Yes,
आपकी
sir.
आवाज कट कट के
Sir, आवाज
Okay,
clear
okay,
नहीं है.
okay. Just a minute, just a minute. Is it any better now?
यस
Yes, sir.
Okay. So today we'll discuss polymorphism. The main topics are introduction to it, types of polymorphism like static and dynamic, and how do we implement these two? What are the different methods? So first of all, what are monomorphic and polymorphic? Monomorphic means which has only one type. The earlier languages like Pascal was there or even C is there, they used to support only monomorphic types. For example, integer, right? Or for example, a function. If you declared a function, it can be used for only one purpose in C. Whereas in C++, you can overload that function. That function can work for different types and for different number of arguments and so on. So polymorphism basically means many forms. One thing may have multiple forms. So what will happen in this case? Different classes or different functions will respond differently to same function call. For example, if I want to add two numbers, now those two numbers may be integer, they may be float, they may be long, they may be mix of integer and float. So one single function may not be sufficient. We may have to write different functions for that. But we want to name those different functions the same. We want to give them the same name, sum. It is possible in only those languages which support polymorphism. Like C doesn't support this, Pascal doesn't support this, Visual Basic or Basic doesn't support this, right? The types of polymorphism are static. Static means something which is done during compilation of the program. Function overloading, which we have done earlier, we'll discuss it again today, and operator overloading. So how do we implement static binding or compile time polymorphism? There are two methods. One is function overloading, another is operator overloading. Then further, operator overloading can be done using two methods, using member functions and using friend functions. Then second type of polymorphism is dynamic binding. That is done at the time of execution of the program or at the runtime. And it is implemented through virtual functions. So you can see the chart here. Polymorphism, two types, compile time and runtime. Compile time further of two types, function overloading and operator overloading. And runtime is implemented using virtual functions. Now, static binding means the binding is done at the time of compilation of the program. Let us take up an example of this. Suppose I want to, I'll be using the same example which we had discussed earlier, right? Suppose we want to draw a line. So I need to specify how many times the character is to be used and which character is to be used. Here I'll write for integer I is equal to 0, I less than 80, I plus out r and del. Now what this function will do, it will draw a line of 80 stars. Now this kind of coding should be avoided. Now it is a fixed kind of function. It has no dynamics in it. You cannot modify without modifying the function. You cannot change how many times some character is to be used for drawing the line. So we can write another function. Let me just copy this. It's a little better. For example, here I'm writing integer n. Now we are specifying that n number of times the star is to be printed for drawing the line. It is a little better. Second, then third function, character C. Now we are specifying that which character is to be used, but it will be used 80 times only. Then the last one, this will specify both the things, integer n and the character C. And this is the right way of doing this. So these four functions, all four functions can coexist within the same program. As you can see, they have same name, draw line everywhere, but they differ from each other on the basis of number of parameters. Like here, in first one, we have only one parameter. In second, first one is not having any parameter. In second, we have one parameter, so they are different. Second and third, they have one parameter each, but their types are different, so they are again different. They can coexist. And fourth function is having two parameters. So let us just call these functions one by one. Draw line 60. This will call the second function. Draw line a hash. It will call the third function. Draw line 40 and tilde character. It will call the fourth function. Let's run it. We will get different outputs. Oh, wait a minute. Here. Okay, fine. So we are getting four different types of lines. In first, there are 80 characters, 80 stars. Second function, as you can see here, it is drawing a line of 60 character stars. Third, it is drawing a line of 80 hash. And last, it is drawing a line of 40. The last one is dynamic. Now, all these four functions, they have same names, but they differ from each other. This is how we implement function overloading. And this is static binding. At what is static binding? When the compiler will compile this code, at the time of compilation itself, it will bind this particular call to the first function, right? Similarly, the second call will be bound to the second function, depending on the type. So this type of binding is done at the time of compilation. Dynamic binding, on the other hand, which we'll discuss a little later, maybe tomorrow, it is done at the time of execution of the program, because at the time of compilation, it may not be possible for you to know, or for the compiler to know, that a call is corresponding to which function. In that case, we'll be using virtual functions and pointers, and we'll discuss it a little later. Now, continuing with this, function overloading, as you can see it here, I have given an example. First function, it will add two integers. Second function, it will add two double values. Third, it may add and then print the sum. So these three functions, they have same name, but they are different either on the basis of types of parameters or on the basis of number of parameters. So you can see it here. There are two methods of overloading functions, on the basis of number of parameters and on the basis of types of parameters. But a very important thing, function can never be overloaded on the basis of its return type. If return type is different, then it doesn't mean that you can overload the function. It will give an error. Okay, fine. This you can go through the presentation. I'll share it with you. Then our default arguments. Sometimes we know that some values are most probable values. We can give those values as default. For example, here I'm writing this and star. Now, what is the meaning of this? Forget all other functions for the time being. What is the meaning of this? It means if value of n is not given by the user at the time of call of the function, then n will assume value 80. It will be its default value. Similarly, C will assume value star. Now, what we need to know here, that this function, this particular function, focus on the fourth function only. If we call it like this, draw line, it will correspond to it. It means you are not passing any parameter at all. And in that case, n will be assuming value 80 and c will be star. So it will draw a line of 80 stars. So it means if this function is there, then first is not required because they both serve the same purpose. And here also, you can see there's an error. It is saying there are more than one instances of overload function draw line, right? So the purpose of default parameter is that if values are not provided at the time of call, then the default values will be assigned to the formal parameter. So first function is not required. Similarly, second, again focus on this function. We are in second call, we are passing only one parameter 60. It means n will assume value instead of 80, it will assume value 60 and c will remain star. So it means this second function is also not required. It is useless. It is redundant here. So the error is gone. But what's about third and this fourth function? Now the order matters a lot. The order in which you have defined the formal parameters, in the same order you will pass the parameters at the time of call. It's not possible, like for this particular call, it's not that you are passing the value of character C and not passing the value of N. No, you'll have to pass the values in this same order from left to right. The associativity is from left to right. You can skip the value of character parameter, like the case in second call. You can skip the second parameter, but you cannot skip first parameter and provide value of second. It is not possible. So these two functions can coexist. There's no problem. So except this call, third, all the other three calls, first, second, and fourth, they correspond to one function only. So this is how we can implement uh, default arguments. This we have done. Now, all default arguments will be towards right side of the argument list. So this is a legal statement. This is illegal. After a default argument, you cannot have a normal argument. Once again, there is a normal argument, a default argument, again a normal argument. This is again illegal. A default argument, normal argument, again a default argument. Again, it is illegal, right? Because if you are not providing value of A in this particular case, if you are not providing value of first parameter, then it will not work. Because for B, you will have to provide the second parameter value, you will have to provide, and so this statement becomes illegal. Simple rule is, look at the very first function, all default arguments should be on the right side of the argument list, right? So look at the last one. All values, all parameters here are default. All arguments here are default. This is also legal. Okay. Next is very important, operator overloading. Now, what is the purpose of plus operator in C or in C++ generally? We use plus operator for adding two numeric values, right? Plus is intended for adding two numeric values. This is its default behavior. Now we want to overload plus so that we may be able to add distances, add times, add some other objects, which is not available in C or C++. It's not available in C++. We want to modify the behavior of plus in such a way that it should be able to add two distances, two times, or any other two compatible objects. Now let's try this. I'll create a class for this purpose. Let's create a class distance. Distance is stored in terms of kilometers and meters, let's say. Kilometers is equal to meters. 0. This is the default constructor. Then distance k integer m, EMS is equal to k, TRS meters is equal to m. Let me write the function display, which will display the values.
गुड मॉर्निंग सर।
Morning.
सर कुछ बच्चे वेट कर रहे हैं ज्वाइनिंग क्लास के लिए, बोल
उनको
रहे
बोलो भाई टाइम से आया करें. I think everybody's been added. Nobody's waiting. यहाँ कोई visible नहीं हो रहा.
हैं।
Last
सर
time
मैसेज आ रहे हैं ग्रुप में भी।
हो गए ऐड जिनके आ रहे थे. You can see nobody is waiting here. अगर होते तो यहाँ आ जाता. Tomorrow onwards, please join by 9:05. No entry will be permitted after 9:05. I'll rather restrict it. It's been open right now. Okay, fine. What we are discussing here. Okay. We are creating a distance class, and then before discussing operator overloading, suppose we want to add two different distances. Suppose we have a distance d1, we want to add two distances. For example, suppose I plus j, these are two integers. When we add these two integers, what we'll get? An integer, right? So when we are adding two distances, what we'll get is a distance. It means the return type should be a distance. So let me write distance. I'm not writing operator overloader right now. I'm simply showing you a function, and then we'll discuss how to overload the operator. So let us have a temporary distance p dot kilometers is equal to kilometers plus d dot kilometers, and p dot meters is equal to meters plus d dot meters. Then it will return t. What this function is doing, it is adding two distances and returning those. Let's take up an example of this now. Distance d1 10 kilometers and 600 meters, let's say. Second d2 12 kilometers and 300 meters, let's say, and distance d3. Then d3 is equal to d1 dot add d2. This is the function we have created. It will accept a parameter of type distance. After that, we have declared a temporary variable. We'll store the sum of distances in this temporary variable and then return it. The type is distance, so return type will also be distance. So here, d3 is an object of distance. It will receive the addition of d1 and d2. So what we are doing here basically, if you look at it, let me write it here, dot add d2. This is what we have done here. We are adding distance d2 to distance d1 and returning their sum. And then let us write d1 dot display, d2 dot display, and d3 dot display. Have a look. These are the two distances we had created, and third one is sum of first two. Is this thing clear? I repeat, we have not discussed operator overloading as yet. But how to add two distances and return the distance? Is this thing clear to all of you? Somebody please say something. Yes, is this thing clear to you?
Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. Now, this is what we have done here. So instead of this, to make it look more natural, if I want to do something like this, right? D1 plus D2. Now, Purpose of plus in C++ is not to add any two distances, but we can overload it. We can define a new behavior for this operator. Now, how can we do this? Now, we'll write an operator overloader. It is basically a function only, but we write it in a different way. Instead of add, I will write operator plus. Simple. One change you need to do. It means you are overriding, uh, you are overloading plus operator, and it will return a distance. So instead of writing add function, I have written operator plus, and then we'll write here D2. It will serve the purpose, and everything else is the same. See, the result is the same. Is this thing clear? Yes. Is it clear? Is it clear to all of you?
Yes, sir.
Still people are joining. That's not good. Okay, let's continue. So what we have done here, we have overloaded this plus operator so that we can make this function look more natural. Now we are adding D1 using plus operator to D2 and then returning the result and storing it in D3. Have a look at the operator overloader function once again here. Okay, now when you are calling this plus operator, it means we are calling it for D1. It belongs to D1, right? And D2 is the parameter that we have passed to the function. Is it clear? Yes, is it clear?
Yes, sir.
Okay. Uh, this is direct method when we are including the operator overloader within the class itself. There is another way through which we can overload the operator, that is through friend functions. Let's try that now. Let me remove it. Let's have some different class for that purpose. Class A, some integer x, x is equal to 10, let's say. Then friend, let it be integer, some A object of A and B object of B. What we have done here, we have declared a function sum as a friend of this class, to which we will pass objects of two different classes, and then it will return their sum. Now here class B is not declared, so what we need to do, we'll make a forward declaration for this. Forward declaration means we have simply declared that there is a class B, but what is contained in it, what is its definition, that may be given later. So here we'll give definition of class B, integer y, public, in its constructor, we'll write y is equal to 20, let's say, and the same declaration, friend integer sum A object of A and B object of B. Now this is an, I had told you earlier when we had discussed friend functions, that a friend function is always an external function. So for these two classes, sum is a mutual friend, but it is an external function. So we'll write integer sum A object of A, B object of B, then return object of A dot x plus object of B dot y. So as you can see, these x and y are private in A because we have not specified any access specifier, so by default they are private. But since sum is a friend of both of these classes, so it's able to access their private members. we'll add those private members and return. Both of them are integers, so return type will be integer. Let's create it here. AA, BB, Cout, AB, and del. Let's run this. See, it is printing some of the values of x and y here. So this is how we implement a mutual friend. But now we are to overload it, right? Here we'll write. Okay, I leave it as an assignment for you. Tomorrow, I would like to see how many of you are able to answer that how a friend function operator overloader can be created. Note it down as an assignment. Friend function as operator overloader. This is your assignment for tomorrow. Okay, let's continue. You can overload many operators, but not all. As you can see it here, almost all operators can be overloaded for user-defined type with a few notable exceptions such as member access, dot and dot pointer, as these are conditional operators. There are few other operators which cannot be overloaded. For example, let me show you. Okay, let us go through this first, then we'll discuss the other thing. Here. So 2 plus 3, when we say, then there are two functions implicitly involved. One is addition of these two and then assignment. So if you look at this statement like this, assign A, what is to be assigned to A? Addition of 2 and 3. So these are basically two functions, right? Which we have converted to operators. For unary operator, it's different. Operator plus, for example, the unary operators that we have are pre-increment, post-increment, pre-decrement, post-decrement, and negation. These are the unary operators. So for unary operators, the method is different, and for binary, it's different. So what are the rules for operator overloading? These are something very, very important. First, only existing operators can be overloaded. You cannot create a new operator, right? Only the existing operators which are supported by the language are only they can be overloaded. You cannot create a new operator of your own. So the overloaded operator must have at least one operand that is of user-defined type. We shouldn't change the basic meaning of an operator. For example, here, once again, have a look. A is equal to, say, we are writing B plus C, where A, B, C are objects of classes. So what is the purpose of this operator? The purpose is to add two values, right? So within the operator overloader, if we are modifying its behavior and you are subtracting it, then it is permitted but is not natural, because the natural behavior of plus is to add two values. If you are subtracting it, it means you are modifying its natural behavior. It is permitted but not recommended. So we should not change the basic meaning of the operators. There are some operators which cannot be overloaded. So these are size of operator. It cannot be overloaded. Dot, dot pointer, scope resolution, and tertiary or conditional operators. These operators cannot be overloaded. And overloaded operators, they follow the syntax rule of original operators. They cannot be overridden. We cannot change the number of operands an operator expects. For example, plus, it will expect two operands. So we cannot change. We should always provide two operands to this. We cannot use friend functions to overload certain operators. For example, assignment, brackets, and member access. These cannot be overloaded through friend functions. Unary operator overloader by means of a member function. We'll discuss this, how to overload unary operators. The restrictions are there. We have discussed almost all those. You can go through those. So these are the operators which can be overloaded, and these are the operators which cannot be overloaded. There are a few more. I told you size of, dot, dot star, scope resolution, conditional. Then there are a few other type ID, static cast, and constant cast. These operators can also not be overloaded. Okay. Now let us move to the next thing: how to overload unary operators. For this, I hope there are no more waiting. Okay. For this, let us take up a different class. Integer x, integer y. Suppose this is a class. Just a minute. Okay. We have got two. Let's have a display function. And then an operator overloader plus plus. What we'll do? What is the purpose of increment operator? It will increment the value and return it. Okay. So first we'll create a temporary object of this class, point p, and we'll pass it two parameters x and y. Even if you don't pass, it doesn't matter. P dot x is equal to plus plus x. P dot y is equal to plus plus y. Then return p. Let's try this. Point p 10 10. Let's say let it be p1. Let's say one more object of it, p2. p2 is equal to p1 plus plus p1 dot display and the p2 dot display. Okay, let's run it now. Very simple class. Let me explain it to you. Two constructors are there. A display function is there. Most important is this plus plus. So what is the purpose of increment operator? It will increment the main argument and then it will return a incremented value. So we have incremented the main values and then return the incremented value as well. So initial value for point P1 is 10 10. After this, it will be incremented and returned. But just a minute. Okay. For pre-increment. Fine. As you can see, it's working. Now, important thing is this is for pre-increment. If I try to use it as a post-increment operator, it doesn't work. It gives an error message, as you can see here. Right? It gives an error message. Then how to implement post-increment? Have a look. We'll use the same one. Very minor changes required. You need to pass a dummy parameter here. You need to pass a dummy parameter. Let it be some A or I. And then it will work as a post increment. First one was pre increment, second one is for post increment. That's how we do it. Now, run it again. No error, and it's working. But for post increment, we need to modify because in case of post increment, first the value is used, then it is incremented. So you need to implement it like a post. Okay, have a look at here again. Now you can see here, in first case, P1 is 1010. We are calling pre-increment. Pre-increment means that first P1 is incremented, then the value is assigned to P2. Both of them will be 1111. So at this point, first the value of P1 is assigned to P2, then P1 is incremented. So P1 after this, P1 will become 12, but P2 will remain 1111. This is how we implement pre and post increment. So if you have any problem, then let me know. Something which is not clear, then let me know. Otherwise, you can watch the video again. Okay, once again, I request you all to join by 11:05 because otherwise it creates a lot of disturbance in the class. Any queries? Any queries, Vijay?
No, sir.
No.
Yes, sir.
Oh, okay.
No,
I
sir.
have given you an assignment. Don't forget to attempt that. Okay.
Okay,
How
sir.
friend functions are used as operator overloaders. We'll discuss it tomorrow along with the dynamic polymorphism. Okay. This is all we have discussed. Dynamic polymorphism is here. Tomorrow we'll discuss that along with using friend functions as operator overloaders. Okay, take care. I'll share the video in a few minutes. Right?
Okay, sir.